Okay, hello. Today we're going to move on to 4.8 complex numbers, and this is going to be the last section that we do in this chapter together. So complex numbers are also known as imaginary numbers. And remember, these are numbers which do not exist on the real number line. And the way we showed that we could, quote unquote, create an imaginary number is by trying to take the square root of a negative number. Because there is no real answer to this, we have these imaginary numbers. So the imaginary unit I is defined as the square root of -1. Because the square root of 4 is 2, the square root of -4 is 2i. And in our last video, we talked about and showed that the square root of 72 was 6 square root of 2, or 6 radical 2. So the square root of -72 is 6i radical 2. So that's going to be important for these. In our first example, we're looking at x squared minus 4x plus 5. So remember, we went back in a few sections ago and talked about some of these quadratics that never cross the x-axis. There's never an x value that makes the function equal to 0, and we said that this meant there was no real solution. However, we can have imaginary solutions, so I wanted to show you that on here. We'll solve it using the same method. A, B, and C are necessary here. So now we've got A is 1, B is -4, and C is 5. For this example, I'll just use our regular quadratic formula. You can always do this if you want. X equals, I'll write it all the way out, -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, -b is the negative version of -4, which is a positive 4, plus or minus the square root of b squared, make sure you put that -4 in parentheses, minus 4 times a times c, all over 2 times a. So then we're going to bring this down and simplify what we can. 4 is just 4, plus or minus, we need to find this square root. -4 squared minus 4 times 1 times 5 is -4. So we're doing 4 plus or minus the square root of -4 all over 2a, 2 times 1, which is 2. So now remember, the square root of -4 is 2i. So we have 4 plus or minus 2i all over 2. And we're not quite done here because we do have that simplification step. We want to see if there's anything that goes into all three of these terms, and there is. We can divide a 2 out of here, and since this 2 divides out, we can just divide the 2 away. We're left with 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, so we're only left with I. And our answer is 2 plus or minus I, because that 2 divides out also, and we're just over 1. Division by 1 just leaves you with the same thing. So we've got 2 plus or minus I for our example. So while this equation has no real solutions, there's not a value for x, a real value that we can substitute in to make it true. We do have these two imaginary solutions, 2 plus I and 2 minus I. And then I'll just do one more with you today, and we can call this video done. So on this one, let's use that discriminant formula. We're still going to want A, B, and C. And this one's a little bit different because we have a decimal, but that doesn't hurt anything. A is 3. B is -9. And C is 8.25. So if we went the discriminant route, remember that's finding the part of the quadratic formula that goes under the radical. So D equals B squared minus 4AC. which is negative 9 squared minus 4 times 3 times 8.25, which is negative 18. So because this is the part under the radical, we know that we are going to have an imaginary number because at some point in our problem, we're going to have the square root of negative 18. So I'm going to go make a factor tree for 18 over here. And we've got 2 times 9, where 2 is prime, and 3 times 3 for 9, where both those 3's are prime. So this is I radical 18, which is I times the square root of 2 times 3 times 3, where our 3's can get married here. They pair up and become 1. So this is 3I radical 2. So then in our quadratic formula, if we break it down as x equals negative b plus or minus the square root of the discriminant all over 2a, b was negative 9, so negative b is positive 9. We just found the square root of the discriminant. The square root of negative 18 is 3i radical 2. So plus or minus 3i radical 2 all over 2 times a, which is 3. So that is equal to 9 plus or minus 3i radical 2 all over 6. And again, we want to see if there's anything that goes into these 3 terms. And there is. We can divide a 3 out of here. So our solution, when we divide 3 out, 9 divided by 3 is 3. 3 divided by 3 is 1, so we get plus or minus I radical 2. And 6 divided by 3 is 2. So this is where I would leave my solution right here. 3 plus or minus I radical 2 all over 2.